Again, today's discussion assumes you have watched lesson 1 and lesson 2 from announcement 3. If you have not done so, I suggest you to watch that first. Okay, and as always, in case you miss any lesson or you want to review any lesson, you can go to your Zoom. Okay, to go to your Zoom, go to cloud recordings, and for now we have the recording from last week. Okay, for now we have the recording from last week. This one here. Okay, this one. Okay, so there are actually two recordings you will watch. The first one is from the announcement number 3. For now, announcement number 3. Lesson 1, 2, 3, 4, 5. Lesson 1, you're supposed to have watched last week. Lesson 2, you're supposed to have watched before the second meeting. And then lesson 3 will be the one you're supposed to have watched before meeting number 3, which is next week. Okay, so lesson 1 before the first meeting, lesson 2 before the second meeting, lesson 3 before the third meeting, lesson 4 before the fourth meeting, and lesson 5 before the fifth meeting. Okay. Now, let's start our discussion. Again, today's discussion requires you to have watched lesson up to lesson 2 from our announcement 3. What will we do today? From those lesson 1 and lesson 2, you have seen that we have two possible situations. They are given population or sample. And the way the data provided to us may be in form of raw data or group data single point or group data interval. So a total of 6 possible cases. Okay, now for each of these 6 cases, we will try to find the mode, the median, the mean, variance, standard deviations. Okay, and except for the group data interval, for raw data and for group data single point, we will be able to find the first and the third quartile. Okay, so this part 1 here will take us approximately 2 hours, maybe even 3 hours, including me asking you to do some problem on your own, and then we review them. Okay, now let's start with an example. Let me grab a problem from my old quiz. Give me a second. Okay, this is a problem from my old quiz. Make it larger. Okay, let's say this is our example 1. Consider the following data. We have 7, 10, 11, 8, 9, 6, 10, 7. And what we need to find are first the mode, the median. Once we are able to find the median, then the follow-up question will be find the first quartile, the third quartile. And then we'll find the mean and variance and standard deviation. Okay, now the thing is, from this data, we don't know if this is a population or sample. Okay, let's first work it out as a population. Actually, the difference that we have later on, if this is population or sample, only when it comes to the discussion of mean, variance, standard deviation. Okay, when it comes to mode, median, first or third quartile, the way it is being done will be the same for both population and for both population and sample. Okay. Now, oh, by the way, so before we really start, let's write down all those formulas for mean and variance for population and sample given raw data, group data, single point, group data, interval. So let's start with the mean. The formula for mean. The formula for mean. If we have population, so population mean, and sample mean, if we have raw data. And if we have raw data, the population mean will be denoted by mu, and the formula is the sum of all data divided by population size. Okay, now while if that is a sample, then sample mean is denoted by x bar, and the formula is the sum of all data divided by sample size. Okay, now what happens if we want the variance? How about the population variance? Maybe I write it this way. For the case of raw data, okay, the mean formula for mean is this. How about the formula for variance? Then variance, population variance denoted by sigma square. It's an O with some hair. Okay, not a theta, not like this. No, not this one, not this one. No, that's not the correct way of writing it. Okay, I know sometimes we get the first time we saw something, we try to replicate that, but not with the same stroke, like with the same direction of writing it. Some people write it this way. Some people write it this way. But it's okay if you write, as long as it looks like this. It's basically a lowercase o with some hair. Okay, that's a Greek lowercase sigma for in Greek character. Okay, and the formula for population variance, given we have raw data, is n times the sum of x squared minus the square for the sum of x over n squared. While sample variance is denoted by lowercase s squared. The formula is very similar, n times the sum of x squared minus the square for the sum of x. So you see the numerator are actually exactly the same except for the letter we use for population or in sample size. On the denominator, however, sample variance has, instead of n squared, is n times n minus 1. Okay, let's box this one. So in case of raw data, then this is the formula for population mean, sample mean, population variance, sample variance. Okay, so now then, suppose we have this question here. Let's treat this as a population first. As a population, suppose maybe no. let's do the mode and median first and third quartile. And then once we talk about mean, variance, standard deviation, then we talk about is its population or sample. So the mode, that's usually the easiest question. I hardly give more than 1 point for mode question. Okay, what's the mode here? What is the most frequent data? 7 happened twice. 10 also happened twice, but that's it. The rest only happened once, right? Okay, so the mode will be 7 and 10. This is what we call bimodal case. Okay, now how about the median? For us to answer the median question and the follow-up first and third quartile, we need to put them in order first. Sort. Put them in order. I know you can do this using calculator, okay, but don't use calculator. Okay, don't use calculator. Well, first, I don't accept answer from calculator. Second, calculator doesn't show you work. Calculator just gives you the final answer. And in my test one, you will see approximately 70 data. So plugging those numbers into a calculator will take you so much time, and so far I hardly get anyone get it right, because like of 70 data, you may end up entering only 68. You know, you miss some numbers, or you type some numbers wrong. So that's not a good idea. Okay, let's see. So when I put them in order, the smallest one is 6, and then 2 7s, and then 8, 9, 10, 10. 8, 9, 10, 10. The last one, the largest one, is 11. Okay, so I put them in order. It's only 8 numbers, as I know, so it's not too hard to put them in order. Now, so of 8 data, then where is the position of the median? Position for median. Where is it located? Because we have 8 data plus 1 divided by 2. That will give us the 4.5 data. 4.5 means the median is located between the 4th data and the 5th data. Right? 4.5 is between 4 and 5, right? Okay, so it's between these two numbers here. So the median will be the average of those two numbers. 8 plus 9 divided by 2 equals to 8.5. Now, I believe I have emphasized very strongly in my lecture that if you are doing the median and the median happens to be between two numbers, then you have to write this. Okay? If it is between two numbers, then the operation that it's between two numbers, 8 and 9, you need to show that 8 plus 9 divided by 2 before you give me 8.5. Now, the weakness of using calculator will only give you 8.5. That's it. Okay, but in practice, if the median is located between two numbers, then you need to say what are those two numbers in computation. Okay, not just like 8.5. Thomas, I look at that, I know the answer. Me too, I know the answer too, of course, but the issue is people who don't know. People who don't know what do they understand? Okay, Olivia, I have a question.
So on the test, when it's not between two numbers, it's just one number. Do you still want it to show x over 2? Or
no. If it is only one number, let's say suppose I don't have this 11. Okay, suppose we don't have this 11. So suppose we don't have this 11. So the median is only 8. Right? And then you just write 8 right away.
Okay.
Only if it is between two numbers. Only if it is between two numbers, you have to show that computation.
Okay, cool.
Okay, yeah, if it is only just that 8, for example, then just write 8 right away. Now, the reason is because if you just write 8, okay, you are actually saying two things. You are saying that the median is exactly 8, of course, that's what you say, but it also means that this 8 is one of the data. If the median is exactly one number, not between two numbers, right? Then the median must be one of the data, right? Now, but when you write it this way, here, then you are telling the audience or the reader that the median is 8.5, but this 8.5 is not one of the data because this is between two numbers. Okay, so even though you answer the median, but at the same time, you also tell the reader that it is between two numbers, therefore the number of data I have must be even. Okay, so if all of the sudden, somebody have make this statement, the median, so there's some data given, right? And then the median equals to 25. Okay, my question to you is, then what part of the data is less than 25, less than or equal to 25? Now, the median is located in the middle of the data if you put them in order, right? If you put them in order. So the number of data that is at most 25 is approximately 50%. The number of data which is at least 25 is also 50%. And the number of data must be odd. Because the only way you don't show that it is between two numbers is when the number of data is odd. While if you show the work the way I show here, okay, then you tell me that approximately half of the data is at most 8.5, and approximately half of the data is at least 8.5. And the number of data in the set is even. Okay, now even if let me change this 9 becomes 8. Even if I change that 9 becomes 8, then the median should still be shown this way. The median, because it's between two numbers, right? Between 8 and 8, you still need to show 8 plus 8 over 2. Even though you and I know that will be 8. But you still show it this way just to tell the audience, the reader, that the median 8 that we get here is between two 8s. Okay, so not by writing it this way, you are telling the audience, the reader, more than just what's the median. You also say that this number may not be one of the data. Okay, now next, how about if this is a population? Suppose this is a population, then what will the mean be? Okay. And how about the variance? Suppose that's a sample. What's the sample mean? And what is the sample variance? Of course, in my test, for example, in my quiz 1, I already posted. In my quiz 1, you don't need to do both, right? You don't need to show population and sample. Just do one of them, depends on the question. Okay, depends on the question. If I say the data is population, then you do the population part. Now, however, before you compute the population mean, sample mean, population variance, sample variance, you always need to compute the following. Okay, what is the sum of the data? And what is the sum of the square of the data? Okay, now use your calculator, please. Find the sum of the data. Basically, you add all the data there. 7 plus 10 plus 11 plus 8 plus 9 plus 6 plus 10 plus 7. When I add all those numbers, the sum of the data is 68. Okay, now, how about the sum for the square of the data? Okay. This means you need to add 7 squared plus 10 squared all the way to the last one, 7 squared. So the sum of x squared means you square each data first and then you add them. It's different from get the sum of all the data and then squaring it. No, it's different. It's different order operations. The first one you square and then you add. The second one, the one on the right hand side, is you add first, in this case is 68, right? We did that earlier, and then you square it. Okay, different order operations. Now, so on your calculator, let me show you how to do the calculator. It's actually just a regular calculator, but I want to show you how it should be done. How it is done. Okay, so I will add 7 squared plus, I don't know what's this here. 7 squared plus 10 squared. Do you see that? Okay, plus 11 squared plus 8 squared plus 9 squared plus 6 squared plus 10 squared plus 7 squared. So I get the sum of the square to be 600. Okay, so what is the population mean? Population mean is the sum of the data, that is 68 divided by 8. Okay, that one's easy. That's 8.5. Now, in my class, when the result you have, the final result you have is more than 5 decimal places, then round it to 5 decimal places, at least 5 decimal places. If you want to keep it 10 decimal places, fine, go for it. Okay, but at least 5 decimal places. Okay, how about population variance? How about population variance? Now, the n is equal to 8, right? I usually call this the first number. Let me put it here. I usually call this the first number. This is the first number. The second number, the third number. Okay, now then, what is the formula for population variance? It is always the first number times the large number, the last number, minus the square of the second one. Let me color it so that you see. The first times the third minus the second squared divided by population size being squared. Okay. Now then we use our calculator. 8 times 600 minus 68 squared divided by 64, I get 2.75. I get 2.75. Now, therefore, continue from here. Then population standard deviation will be the square root of 2.75, which is 1.65831. Okay, that's the population mean, population variance, then population standard deviation. Now, what happens if we talk about sample instead? Well, then instead of dealing with population size, we have sample size right now, but the same number, right? You see, that's the same number. Now, what is the sample mean? Sample mean will be the same computation. Okay, so 68 over 8, that's 8.5. While if we compute the sample variance, that will be on the top, that will be exactly the same, 8 times 600 minus 68 squared. The denominator is where it gets different. Okay, the denominator will be n times 1 less than n. Okay, so instead of dividing by 64, will we divide by 56? Okay, I get 3.14 something something something. 2857, so to 5 decimal places I rounded to 6. Now, sample standard deviation is therefore equal to the square root of that number. Okay, so I get 1.77281. Okay, now any questions so far? No question? Okay, let me ask you to do one problem then to replicate similar situation. Give me a second. Okay, let's say we have this data, example 2. Let's say we have this data. Okay. Just for sake of simplicity, let's call this population. I have a message coming in. Let's see. When we have our final answer, how do you want us to show it? I want to show it basically this way, including all the work. Yeah, including all the work. Like that. Okay, not just the final answer. No, I don't want just your final answer. No, not only the final answer. Your answer should be including the word. Okay, yeah, the answer should be including the word. Another message coming in. Do we box our answer? Well, you can. You can box your final answer, but you don't have to actually, because when I grade it, I basically grade your work also, right? Okay. Okay. Now let me ask you to look at this question then, and you will answer find the mode, the median, the mean, actually first quartile, the third quartile, mean, variance, and then standard deviation. I just realized that I forgot to mention something there. Let's go back above first. Hold on, because I think up here I forgot to mention, I forgot to do the first and the third quartile. Give me a second. Okay, yeah. Give me a second. I need to put some insert here. doesn't look like. Well, anyway, I will just continue from here then. So what is our first quartile? First quartile, you need to first see what is the lower half of the data. Okay, now the median cuts in between these two numbers, right? Oh, it should be 9 earlier. Should be 9 here. The median cuts between these two numbers. For notation purpose, what wording indicates if it is population or sample? Usually, it is explicitly given its population sample, but sometimes it's implicitly given. For example, instead of saying it's a population, I say that, oh, the following data is from all students at East LA College. So the word all there implies population. Okay, or to say samples, for example, well, they are students take common statistic class, and the following is the scores from 10 students. Okay, now you know that more than 10 students taking my statistic class, right? Okay, so if you get only 10 of the those students, then it must be sample. Okay, so sometimes it is explicitly told this is a population, this is sample. Sometimes it's not. So you need to see from the wording. Okay, does it make sense? Of course, then you may ask me this, but Thomas, why don't you just tell us explicitly population or sample? Well, that's actually part of your critical thinking though. Okay, suppose you are given some data. Okay, can you tell from the context if that data is from sample or that data from population? Okay. Now, coming back here. Since the median is between these two numbers, okay, then the lower half will be including that 8. Now, notice that that 8 is not the median, right? Notice that 8 is not the median. The median is on the 4.5 data. So it's between data number 4 and data number 5. So data number 4 is part of the lower half, and data number 5 is part of the upper half. Okay, now then the first quartile is the median of the lower half. Now, if you see the lower half here is 6, 7, 7, 8. So the median is between these two numbers, right? Now, since it is between two numbers, then I have to write it this way again. Okay, and the third quartile is between 10 and 10. So I still need to write it as the average of two numbers. Okay, that's how it is being done. Now, for sake of clarity, let's see, suppose I take away one of the data. Suppose the data is only 6, 7, 8, 9, 10, 10, 11. Now, you always need to find the median first. Now, from here, we see that exactly 9 is the median. Exactly 9 is the median. Okay, so if that's the data, there are only 7 data. Okay, then 9 is the median. The lower half will be the numbers to the left of that. This is the lower half. Basically, keep in mind that we never include median in our lower half and never include median in the upper half. Okay, so 6, 7, 8 is the lower half. Therefore, the median of the lower half That's our first quartile is 7. The median of the upper half, that's the third quartile, is 10. Okay, so keep in mind the median does not include the lower half and upper half does not include the median. Now, let me ask you, come back here. Let me ask you to do this then. The mode, the median, first quartile, third quartile, the mean, the variance, and standard deviation. Okay, go ahead, do this. Let me give you 1, 2, 3, 4, 5, 6, 7, 8 minutes from now. So 8 minutes from now will be 9:05. Okay, please do that. I will stop the recording. Okay, I will start working on this. You may not be done yet, but you can continue working. Okay, so solution, the mode, as I see here, are 31 and 24. I think those two only. Okay, and then for me to get the median, I need to put them in order first. The smallest number is 22, and 23, and 24, 24, 26. And then 31, 34, 31, 31, 34. So the median is between two numbers that will be between 24 and 26. The first quartile, because the median is between 24 and 26, so the lower half is including the 24, the upper half including the 26. Okay, so the first quartile will be 23 plus 24 over 2. That's 23.5. The third quartile will be between 31 and 31. Elizabeth, you happen to write on my stuff. Can you delete it? Thank you. Okay, now then, before we compute the mean, variance, and standard deviation, let's find those three numbers first. N is equals to 8. The population size is 8. I need to find the sum of x and the sum of x squared. Now, what is the sum of x? Anybody can help me? What is the sum of x?
215.
215. And how about the sum of x squared? I get 5919, is it right? Let's compute it. Yeah, I get 5919. Okay. Not 46,225. The reason you get 46,225, I believe, because you square this. Okay. But the square of 215 is denoted the sum of x being squared. Okay, that's 40,000 something. Okay, 46,225. The sum of x squared, again, is done by doing the following computation. It's 31 squared plus 24 squared plus 22 squared, all the way to the last one, 24 squared. You don't add first and then square. You square each one of them first and then add. Okay, give me a second. Okay, now then the population mean will be the sum of the data divided by 8. 215 divided by 8, that is 26.875, while the population variance will be the first number times the last number minus the middle square over the population size square. What is n? N is the population size, the number of data in your population. Watch my lecture video lesson 1 and 2. The capital N denotes population size. Lowercase n, if that were sample, and then it's sample size. Okay, capital N is different from lowercase n. Now then I continue with this computation. This will give me sigma squared equals to 8 times 5919 minus 215 squared. That's 1127. Let me write it down. Divided by 64. That's 17.809375. So I use 38. Therefore, the population standard deviation is the square root of that. My daughter is 13 months, 13 and a half months. And she's next to me. She wants to play with me. Okay, somebody mentioned about boxing your final answer. The way I box my final answer, I use this notation. I do it this way. Now, if anybody saw you doing this and that person took my class before, that person must recognize you right away. That person must say, oh, you took Thomas' class, because only Thomas doing it like this in the whole LA. I think even in the whole United States. Only Thomas doing it that way. Well, anyway, this is if we have population. Now, let me modify the question a little bit. Example 3, and let's call that sample. Okay, and then, hold on, I want to use this data again. Use this data again, but I add one more number. I will add 24. So instead of population, now let's see this as sample. And I want you to answer the same questions. Find the mode, the median, the first quartile, the third quartile, the mean, the variance, and the standard deviation. Now to help your computation then, now you see that your n, because this is a sample, then we use lowercase n. Lowercase n will therefore will be 9. The sum of the data will be 239. The sum for the square of the data later on, you will see to be 6,495. I hope that simplifies your, help you with your computation. So let me give you 1, 2, 3, 4, 5, 6, 7 minutes for this. So 9:22. Okay, try it. Not be done yet, but let me start working on this. The mode, I believe, is now only 24. Is it right? 24 happens 3 times. Okay, only 24, not 30, not including 31 anymore. And then how about the median? For me to answer the median, I need to put them in order first. So sort 22, 23, 24, 24, 24. And then 26, 31, 31, 34. So the median will be exactly 24. This is the median. Therefore, the lower half is anything before that. That's the lower half. And this is the upper half. Okay, notice that 24, the one that I circle, is the median. Now, anything to the left of that, including the other 24, is part of the lower half. Okay, so the first quartile will be between 23 and 24. So the first quartile will be 23 plus 24 over 2, that's 23.5. While the third quartile is between 31 and 31. Next, what's the sample mean? Sample mean is, why do I need that long? No, I don't need that long. Sample mean will be 239 divided by 9. I get 26.5555555, but the next number is 5 or more, so I round it up. While the variance, sample variance, will be sample size times the first number times the last number minus the middle number square. Okay, divided by, now because this is a sample, then it will be 9, the sample size, times 1 less than that. Okay, so 9 times 6495 minus 239 squared, 1334 divided by 72. That is 18.52778. Now, sample standard deviation, therefore, is the square root of that number. So I get square root of 18.52778. That gives us 4.3043. Okay, now that's for example 3. So this is basically how we do our raw data. If it is sample, if it is population, how do we find the mode, the median, first quartile, third quartile, the mean, the variance, the standard deviation. Okay. So even though it seems like we have a lot of questions, each one of them is actually quite short, except the variance, right? But each one of them is actually quite short. The question I usually get before the test, especially on the first day of class, in almost all of my class on the first day of class, somebody will ask me, Thomas, how many questions you have in your test? And I usually get confused in answering that question because what? How many questions we have done actually so far? Do we answer 3 questions or do we answer 21 questions? Right? Because there are 3 examples, but in each examples, I ask 7 questions, right? Okay, so maybe to be more precise, we have done 3 big questions, but including the A, B, C, D, the parts, that's a total of 21 questions. Okay, so in my test, how many questions there? Actually, I don't know. Okay, but instead of you asking me how many questions, how about you go to my website and see it on your own? Okay, because I don't just tell you how many questions there, I give you my old tests, right? Okay, so make sure you study from my old tests. And you study that not the day before the test, no. I will remind you again when the time is about to come. I will remind you again that, hey, you know what, you can do this problem, you can do this problem, you can do this problem, you can do this, prepare for your test, okay? Now, next, what happens if we have group data single point? What happens if we have group data single point? Let's make a distinction first between group data single point and group data interval. I will show you examples of what we call group data single point and group data interval. Our textbook don't use this terminology, just like a lot of all other textbooks. They don't use the terminology group data. They use frequency distribution. Okay, they use frequency distribution. The term group data is actually purely purely from me. I mean, I'm the only person use that terminology, group data. Okay, you can also call that frequency distribution. Now, this is an example of group data single point. Okay, that's the example of group data single point. And let me give you an example of group data interval. This is the example of group data interval. Basically, we put them in group. Our textbook called that frequency distribution, and that's actually the correct terminology. Okay, both of them are called frequency distribution. Both of them are called frequency distribution. Okay, frequency distribution always have 2 columns. The first column is the outcome. The second column is the frequency. Okay, frequency distribution consists of only 2 columns. Now, in my class, I use the phrase frequency distribution and group data interchangeably. Now, however, with me, I go into further distinguish. I distinguish group data frequency distribution single point and frequency distribution interval. Okay, now group data interval means in the classes, in the outcome, instead of only one number, it's an interval. The one here, single point, is only one number. It's only one number. The treatment for those two are different. Okay, the way we treat them are different. Okay, now, so let's start. If we have group data or frequency distribution single point, the treatment for population will be different from the treatment for sample, at least the notation. Okay, population mean will be denoted mu equals to the sum of fx over lower capital N. If you compare with the raw data case, mu equals to the sum of x over N. Notice that we insert the frequency after the summation notation. Okay, so basically before we add them, we will extend this table first. Okay, get f times x. Okay, and then the sum of fx is the number you get here when you add that column. Okay, now sample mean, the same way, it's the sum of frequency times the outcome divided by lowercase n. If you compare to the raw data case, x bar equals to the sum of x over lowercase n, and we insert frequency after the summation notation. Okay, so I hope this helps you later on in memorizing the formula. How about the variance? Population variance, just like before, is denoted by sigma squared. The O with some hair. Okay, and the formula is basically the copy paste from the raw data case, except that we still insert frequency after summation notation. Okay, so in our raw data formula, we don't have this frequency there. We don't have that frequency. But because we have group data now, then we have frequency inserted after every summation notation. For the sample variance, also the same. S squared equals to n times the sum of fx squared minus the sum of fx being squared over n times n minus 1. Now, if you look back to your notes, the formula for sample variance, raw data will be without that frequency. Okay, I can show you. I can show you. You see the formula here? Notice that we don't have frequency here. Now, when we have group data, then you insert frequency, and then you insert frequency. Okay. Yeah. Eventually, you will memorize the formula. Okay, but what is more important is, like what I said in my lecture, is that when you read the formula, can you replicate the procedure implied by that formula? Okay. Now, plenty of teachers, plenty of instructors, they don't give you these formulas. They just tell you how to use calculator. That's why they insist to use TI-84. If you use TI-83, then TI-83 cannot do this. TI-84 can do group data, single point. TI-84 can do group data single point. Okay, you punch the numbers into calculator and calculator will compute it for you. Okay, but the way I see is this: your instructor, therefore, do not train you how to read a formula. Thomas, I just need to pass this class. Unfortunately, the way I train you is I assume you will continue with your master's, or for most social science right now, you need to take another stats class at 400 level. Okay, at that time, you have to do this already. Okay, no more TI-84 because you are dealing with data like not 40 data, not 60 data, okay, which is still can be handled by TI-84 hardly. Okay, you will be dealing with thousands of data, right? Now, but when you deal with thousands of data, then you need to use computer already. You cannot use TI-84 anymore. Okay, yeah, TI-84 cannot handle it. I have TI-84 plus. That is that okay to use for the class? That's what I say you need for this class. You need TI-84 plus. Okay, you need TI-84 plus. What I'm saying is, like, when it comes to this computation, I need you to show me what I did here. Okay, I need you to show me what I did here. Don't tell me, Thomas, I used TI-84 and this is the answer I get. Okay, first, most of the time it's wrong. Okay, in the last 5 years, I have only one student get it right at the end, because I don't give you only 8 or 9 data. Let me show you in my old test. Okay, let me show you in my old test. Give me a second. So if you come on my first day of class, then you must have seen one of my old tests, right? I show you my old test, but let me open it here. Give me a second. I need to look for it. Now, this is my spring 17 test one. You want to key in all this data here? By the time you key in all this data here, okay, before you answer any question, I really tell you, you need to check again. You need to check again if you don't miss any number or you type too many one number. Okay, we basically will spend at least 10 minutes just to plug in the data. Okay, and when it comes to the median, if you just give me the answer from the calculator, I will penalize you 1 point, because from here I can tell the median should be between two numbers. Okay, so you're supposed to say something plus something over 2 equal to what? Okay, and calculator does not have answer for mode. Calculator does not answer mode. Okay, your first quartile, third quartile, you will see later on, it will be between two numbers again. Okay, very likely, I'm not sure. Okay, but if there were between two numbers again, then you miss it again. Okay, calculator definitely cannot do number 6, cannot do number 7 from my old test. Okay, calculator will not be able to do number 8 because we do it from copy from number 6. Okay, and number 6 is something your calculator cannot do to start with. So no, don't use TI-84. Is it for every data we have there? What do you mean by is it for every data we have? I see from the chat, is it for every data we see there or just one? Yeah, this data set that we have here will be for question number 1 to number 9. So up to number 9, you use the same data set. Okay, you will use the same data set. Okay. And if you see my old tests, my question number 1 to number 9 are all the same question. The difference will be just the data. I give you different data every semester. Okay, and yes, it will be this size. Okay, it will be this size. I will not give you like only 8 data, 9 data. Okay, to say it another way, okay, let me go back to my notes. To say another way, suppose we do research on how students supposed to study math in California. Okay, this is a real case though. This is a real case done by an English teacher at Cal State Dominguez Hills around 10 years ago. Okay, one teacher, one professor at Cal State Dominguez Hills tried to come up with a method how to teach math students doing better math. Don't forget that she is actually an English instructor. Okay, and she did research on how many students? On 8 students. And the result she gets, she tries to tell community college instructors in California that her method is better based on 8 students, and try to replicate that to hundreds of thousands of students. The strange thing is she was an English professor. When I look deeper into what she did, I say, no, you can't do this. Okay, you cannot base only on 8 and say so much about like hundreds of thousand people. Even if you make it 30, somebody will still question that, right? Okay, so what happened if somebody make an inference about people in your group, let's say those Indonesians are stingy. I'm Indonesian, by the way, so don't take offense, okay? Those Indonesians are stingy. And then how do you know Indonesians are stingy? Well, I have some friends, Indonesian friends, they're stingy. How many Indonesian friends do you have? I have 5. Okay, so you talk about all Indonesians based on 5 people that you know, okay? Which very likely, you remember people say that like minds usually flock together, okay? You call these 5 people stingy in a group of stingy people. You even call that stingy people club. Okay, and then based on that, you say all Indonesians are stingy. Come on, man. There are at least 320 million Indonesians. And you want to talk about all these 320 million Indonesians based on what you say from 5 people? No, right? Okay. In other words, for us to infer from the data we have, your sample size need to be big enough. Not this small, not even this small, not even this small. Okay. We start with a small data. Okay. We start from small data. But with the computing capabilities we have right now, you can easily find a lot of cases that are have you ever heard, you must have ever heard AI, right? AI, artificial intelligence. For example, Tesla, right? Tesla have self-driving car. Okay, it's not perfect yet, but how do they teach those cars to self-drive? They use big data. Okay, when we say big data, it refers to millions of cases put together and using these cases, this data to tell us what to do in what case. Okay, now, so no. It's not I'm saying that TI-84 is wrong. No, TI-84 can only handle certain amount of data. Okay, once it passes, like, let's say 300,000 data, now it will show you error. It cannot even handle that many data. Okay, so I show you the formula. I want you to show me the work, even though the number of data I still give a little. Okay, now this is the formula for group data single point. Now let's use this question, the one I had earlier. Give me a second. let's say we have this group data single point. So call this example 4. Let's make sure we know what this frequency distribution implies. Okay, now the first column is the data. The second column is the frequency relates to that, correspond to each data. So we basically can say that if we rewrite this as a raw data, if we rewrite this frequency distribution as raw data, it will show up as the following. 3 happens twice. 4 happens 3 times. 4, 4, 4. 5 happens 5 times. 6 happens 7 times. 7 happens 3 times. Okay, if you rewrite it as a raw data, that's what it looks like. Okay, so to answer the question, suppose this is a population. Suppose this is a population. What is the population size? The population size is not 10, but I saw 10 numbers there, Thomas. There are 10 numbers here. Well, that's not what this frequency distribution means. This frequency distribution means that 3 happens 2 times, 4 happens 3 times, so on and so forth. So the population size should be the sum of the frequency. Okay, so the population size will be, in this case, if I add this, I get 20. That's the population size. Okay, of those 20 data, 2 of them 3s, 5 of them 5s, okay, 7 of them 6. Okay, if I rewrite that as raw data, that's what it looks like. Okay, so from here, what is the mode? Then see what is the most frequent data. What is the highest frequency there? The highest frequency is 7. Okay, that's for outcome 6. So the mode is 6. 6 happen the most frequently, and you can see from the raw data here to confirm. Okay. Now then, how about the median? The way we compute the median, we need to put them in order first, right? But this is basically already in order. This is basically already in order. There are 20 data at 1 divided by 2. That will tell us the position of the median. Where is it located? So it is 10.5 data. It's between data number 10, data number 11. Now then, what is data number 10? The first 2 is 3, the next 3 is 4, the next 5 is 5. So if you look at the cumulative, this is the cumulative is 2 here, up to here is 5, up to here is 10. So data number 10 is 5. Okay, think of it this way. Let's turn our attention to here. Okay, what is data? The first 2 data, the first 2 data is 3. The next 3 data is 4. The next 5 data is 5, right? So data number 10 is 5. Data number 11 is 16. I'm sorry, it's 6. Data number 10 is 5. Data number 11 is 6. Okay. Now, the thing is you need to learn how to read it from the frequency distribution. Okay, we need the 10th data, right? So 2 plus 3 so far is 5 plus 5 so far is 10. So the last data of this row here, this class here, is data number 10. And the next data number 11, is already get into this class. Okay, so the median will be between data number 10, which is 5, and data number 11, which is 6. So the median is 5.5. Now, because the median, the position of the median is the 10.5 data, therefore, there are 10 data to the left in the lower half, to the left of the median. There are 10 data in the lower half. Now, if we have 10 data in the lower half, then where's the position of the first quartile? The position of Q1 will be 10 data plus 1 divided by 2. That's the 5.5 data. It means it is between data number 5 and data number 6. Now, what is data number 5? Okay, the first 2 is 3, the next 3 is 4. So data number 5 is 4. You can visualize that here. 1, 2, 3, 4, 5. So data number 5 is 4. Data number 6 is 5. So the first quartile will be 4.5. Now, the third quartile will tell us the same position from the top. So the 5.5 data from the top is between data number 5 from the top, which is 6. Data number 6 from the top is also 6. So the third quartile is 6. Now you can see from here, from the top, 1, 2, 3, 4, 5. This is data number 5. And this is data number 6 from the top. So you do, on your frequency distribution, you do the cumulative from the bottom. Okay, from the highest outcome, 7. The top 3 is 7. The next 2, which is the 5th data from the top, the next 2 data from the top is 6, and then another 6. Okay, if you put these like this. Now the thing is, we have only 20 data, so it seems like it's still okay for us to write it this way, right? But in my opinion, you should train yourself what happens if we have very large number here. And you end up with, let's say, 2,000 data. I don't think you want to rewrite them anymore, all 2,000. No, I don't think that's what you want to do. Okay, so practice doing it this way. Okay, don't worry, we will have more examples to do. So after this, I will ask you to practice. Now, go further. Then how do we find the mean and the variance, Thomas? Okay, to find the mean, I need to do extension. Okay, Notice that so far we already have n, right? That's the population size. I need the sum of fx and the sum of fx squared. The sum of fx means I need to extend this table. I call that the first extension. Fx equals to, you take the product for each column, for each row. 3 times 2 is 6, 4 times 3 is 12, 5 times 5 is 25, 6 times 7 is 42, 7 times 3 is 21. The total is 8, 10, 16, 1, 4, 106. So the sum of fx is 106. Therefore, we now can answer the population mean already. 106 over 20. I get 5.3. That's the population mean. Now, how to get fx squared? The sum of fx squared, you need to first do x squared. You square all the data and then multiply by the frequency. Okay, so this is 9, 16, 25, 36, 49. How do you get those numbers, Thomas? I'm squaring this x. I'm squaring this x. Okay, that's what I do. Now, once you get the x squared, then multiply each x squared by the frequency. Multiply each x squared by the frequency. So this x squared here, multiply by the frequency. Okay, that will give you 18. Okay, 16 times 3, I believe that's 48. Notice that this 18 is not 6 squared. So please do not think that to get this one, you square the fx. No, that's not right. No, it's not. Okay, at least from the numbers you see there, 6 squares is not 18. Okay, but what makes you think that some students incorrectly thought fx squared is the square of fx? That's because of this misunderstanding. Fx squared is not the same to fx being squared. No, they're not the same. Okay, the notation on the left means you square the x first and then multiply by the f. The notation on the right, you multiply the f and x first and then you square it. Those are two different operations. And we actually knew it from algebra 1. From algebra 1, we have this. For example, 3x being squared. This is equal to 9x squared. Okay, you square the 3, you square the x, right? Now, this is different from 3x squared without that parenthesis. No, they are not the same. Different order operations, okay? The one on the far left here, you square the x first, then multiply by 3. This guy here, you multiply by 3 first and square the product. Okay, that's a very common mistake though. That's a very common mistake. But I can tell you this, whoever does that mistake, never really do it themselves, for sure, so that they don't see their mistakes. Okay, so if you don't practice at home, okay, I will know it for sure. What's the reason? Okay, it will reflect from your work. Okay, but Thomas, why you make it so hard? Because this is transferable course. Okay, and telling me that you are not supposed to learn something hard for transferable is actually degrading yourself, don't you think so? You are telling me that you don't have the capability to do hard stuff. Imagine if I were the one telling you that. It's like, no, don't do hard stuff, just do easy one. You won't be able to handle it. What will you do if you hear a teacher saying that? Like, offended, right? Okay, then why do you offend yourself? No, don't think that way. You are able to do it, of course, with some practice, right? Okay, you need to practice. I'm not saying that you are smart, that you don't need to practice but still get it. No, no. I'm saying that you are smart enough such that you will practice to internalize this. Okay? After all, this is just procedure. With some practice, you'll be good, you'll be okay. So it actually doesn't need to be, you don't need to be smart to do this. But of course, you need to be wise. Okay? So let me make it clear. I'm not trying to make my course easy. I need to keep the level of this course to be transferable. That's one. Okay. Second, the reason I teach you this stuff, which you think is hard, is because I know you can handle it. Saying otherwise is offensive to my students. Okay. Some teachers I know, they don't want to teach hard stuff, but that's what they say implicitly, and you should be implicitly offended. Okay. To be honest with you, I kind of like get tired when people say the word offended, especially with the recent narrative we have after the election. Even throughout the election, it's just like, man, my Facebook is full of those two group of people fighting. Okay, I mean, they can't even sit down and look at the data and do some statistic. I mean, of course, they won't be able because they don't take statistic. And when they did it from easy teacher. Okay, the sad thing is they pass with an A and think they know stats until they realize that, hey, you know what? I'm talking to you as a stat teacher, like my friends, right? Just like, no, when we look at the same data, but the way he analyzed it is different from mine. Why? He doesn't get used to do statistic. Anyway, I'm sorry to fan my anger to you. But trust me, the past election disgusts me just like for a lot of people. And when I look at your response for quiz 0, yeah, that's what happened too. Yes, I have question, Ludin. Somebody raise hand.
Sorry,
Oh no, that's okay.
what you call it? For the fx square, do we add all of them after or?
Yes, you will add them after. So after we're
Okay.
done with
Yeah.
this number will go here.
Okay.
Okay.
Thank you.
Yeah, yeah. Let me come back. Thank you for pull me back from my. Uh,
No,
okay,
it's
you
fine.
see.
Sorry.
No, no, no. I kind of like get distracted, carried
Yeah,
carried away with that. It's just so hurtful.
it's
Uh,
okay.
for
Sorry.
for a lot of people, so for a lot of people, I'm not alone. I'm not alone. It's just like I have to unfriend some people in my Facebook group.
It's
Well,
okay.
anyway, come back here. So this is 147, right? Now, when I add them, I get 18 plus, am I recording this? Yes, plus 48 plus 125 plus 252 plus 147. So I get 590 here. I hope I don't make any miscomputation. So the sum of fx squared is 590. Now, therefore, the population variance will be the first number. Remember the way the numbers later on listed here is in this same order. Oops, sorry. The first number is in yellow, the second number in blue, the third number in green. Okay, also in that order. So when we do our variance, I hope the setup make it easier for you to remember what to do. And the setup that I show you here, the setup that I show you here is a common way to do that though. Like if you ask every statistician to perform this kind of computation, they will do it exactly the same way. Okay, they will do it exactly the same way. And trust me, those statisticians, no, they don't use calculator. They use Excel. Okay, so if you ask me to do this for a project, something that I get paid for, then I will do my numbers on Excel. Okay, but not TI-84. No, no, I will not do that. The population size definitely will not be only 20 anyway. If it is only 20, nobody will pay you for that. Right? It's too easy to do. Okay, now then let's compute this. 20 times 590 minus 106 squared will be 564. So sigma squared equals to 564 over, I'm sorry, my denominator should be 20 squared. Okay, so divided by 400, that gives me 1.41. Okay, now furthermore, therefore, my population standard deviation is the square root of that. Oops. I get 1.18743. Now, for now, I don't give you the interpretation for standard deviation yet. I think you must have seen that in my lesson 2, or maybe lesson 3, very likely lesson 2. Okay, but even if you see it there, that's just a very brief interpretation. The use of mean and standard deviation can be seen in part 2 after later on, okay, after our long break. In my class, I will give you 2 breaks, one short break, approximately maybe in another 10 minutes, okay, and then long break around 12 o'clock. Now, the first break, I will give you 10 minutes. The second break, I will give you 20 to 30 minutes because that's including, I assume that you will take, you will have your lunch. In my on-campus class, that's what I did. Okay, now I hope you really get your lunch though. I assume you're at home or in your office. Okay, hopefully that coincides with your lunch hour if you happen to be at work and listen to this. Okay. Now that's if we have population. Let's do one example. Let me ask you to do one example and just let's keep it as a population for now. Okay, that requires you to know how to read the data though. Okay, especially find the mode, the median, the first quartile, the third quartile, and perform such computation. Okay, let me see from my old quiz. Maybe this one. Okay. Let me ask you to try this example, call that example 5. Example 5, suppose we have this population. Enlarge that a little bit so easier to see. And the question will be, find the mode, the median, the first quartile, the third quartile, and then extend the table to find the population mean and population variance. Okay, population standard deviation just square root of population variance, so that's just one step work. Okay, let me give you maybe let's do it this way. Let's do it this way. I assume it will take you 10 minutes to do this. Okay, I assume you will take you 10 minutes to do this, and then continue with 10 minutes break. So we will come back at 10:32. Okay, what I want you to do right now is copy this down so that I can move my screen here. Are you with me? Okay, so that you can replicate what I did to this problem. Okay, so for those who actually listening to me right now, the one in class synchronously with me, let me give you 1 minute to copy this frequency distribution. And then I will move my screen to the previous example so that you can see what we did there. Oh, 10:32. Okay, let's start the mode. From what we see here, the mode is 17. The median, I need to find the total first. What's this? 8, 16. So the position for the median will be, I do it on my scratch work here, 16 plus 1 over 2, that's 8.5. So data number 8 and data number 9. Data number 8 is 2 plus 6, 8. So data number 8 is 17. Then data number 9 must be 18. That's 17.5. So the median happens to be right in between here. In between. So the lower half will be this group here. There are 8 data. The median of the lower half, there are 8 plus 1 over 2, that's 4.5. Data number 4 is 17. Data number 5 also 17. So the first quartile will be 17 plus 17 over 2, that's 17. Now, data number 4 from the top, from the highest data, data number 4 is 18, right? Because the top, the highest data is 20, and then there are 219, right? So the data number 4 from the top is 18, data number 5 from the top also 18. So the third quartile will be 18 plus 18 over 2, that's 18. Now, just a little interruption. I think if you read chapter 1 and chapter 2 especially, maybe chapter 3, you may have seen this kind of notation. They call that box plot. Okay, or whisker plot. Now, what does this notation mean? This means this number here, the number that you put for this, 17.5, is the median. Okay, the first quartile, it will be placed here. The third quartile will be placed here. Okay, now the number here will be the minimum data. In this case is 16. And the maximum will be 20. Okay, so by showing you this this notation or this diagram here, you know that the minimum is 16, maximum is 20. Okay, the median is 17.5. The first quartile is 17. The third quartile is 18. Now, that also means that approximately 25%, approximately 1/4 of the data is in this interval, approximately another 25% of the data, 1/4 of the data in this interval, another 1/4 will here, another 1/4 is here. Okay, that's what that notation means, the box plot diagram. Let's come back. And how to find the population mean? Population mean, oh, I need to extend this. To extend this, the first extension is for fx. The second extension for x squared and fx squared. This is 32, 102, 90, 38, 20. So 12, 113, 18, 2. Now, let me know if I happen to do it incorrectly though.
I got that.
Okay, thank you. 256 here, 289, 324, 361, and then 400. Now don't add this part though, okay? Don't add that part. And then this will be
Numbers are looking good.
so far. It's not about not looking good. Remember that I told you that we will have 3 numbers. Okay, if you add that here, you may think that's the third number. You see what I mean? You may think that's the third number. Remember the yellow, blue, green, right? The green is here. The third number is here. Okay, but if you put a number there, you may think incorrectly that that's the third number. Okay, I have seen that in the past. That's why. But on the other hand, we don't do that either. Yeah. Oh, somebody did that. Yeah, somebody did that. So I really want to say told you. Okay, but it's good that if you make that mistake, okay, if you need to make any mistake, do it now. Okay, so that with some practice, then you see, oh, I make mistake here. Sometimes with one mistake that you make, I mean, I make mistake too, a lot of mistakes. Okay, but I learn from my mistakes. Some people don't learn from their mistakes. Okay, but at least with mistakes, we have a chance to learn from that, right? Okay, now, so I don't expect to find somebody without mistakes either. Okay, because then that person do not know what it feels to ever fall. But don't worry, if you need to make any mistake, do it now. Okay, times 289, the number is quite big, so I cannot do it mentally. 1734. 5 times 324, that's 1620. And then this is 722, and this is 400. Which if I add, I will get 8 in the units. 1 plus 2 plus 4 plus. So this is another 8. So 12, 18, 29. So 4,988. Can anybody help me confirming it?
That is correct.
Okay, thank you.
You're welcome.
Either both of us make mistake, which is very unlikely, because if you make mistake, very likely it's different from my mistake. Right? That's why I asked you, did you get it right? Yeah. Otherwise, then I use my calculator to confirm. But thank you. So 282 divided by 16. That will be 17.625, while the variance will be, let me move that a little bit to the left so that I have enough space. Maybe I do it now here. So the variance will be 16 times 4988. 28 minus 282 squared over 16 squared. 16 times 4988 minus 282 squared divided by 16 squared, I get 1.109375. Then the standard deviation will be square root of that number, right? Do you get the same thing so far?
Yes.
Okay, great. So that's 1.05327. I have to be honest with you. I have to be honest with you. For this whole semester, the most difficult day is today. So if you survive and fully understand what we do today, I have very big hope that you are actually fine. Okay, the way you study is already correct. Okay. so I mean, yes, there's only a limit on how hard the topic can be. Okay, and of course I still try to be as reasonable as possible. I need you to be good when you transfer to 400 level statistic class, but at the same time I'm not teaching you that level. I'm teaching you still this level. Okay, so and based on my experience, students who can handle this second day of class lesson, okay, tend to be okay. Now, students who, there are some students actually take some time to really get it, okay, but most students who actually do well in the second day of class or whatever I teach here, they tend to be okay. Of course, there are some students who did okay right now and still don't pass the class, but it's usually because some external reason, like, you know, I have cases where suddenly they get sick, or the worst part is like, I mean, I say the worst because this is quite the bad one. Like me, I imagine I can do so well in my math, but it just take one of my children, let's say my son gets sick for 1 week, and it will throw me off with all the lessons at my school. You see what I'm trying to say? Okay, because once somebody important in your family gets sick, for example, you cannot take your mind away from that. I mean, however smart I am in math, but if my son or my daughter's the one getting sick, I don't think I can think. I suddenly becomes like just lost. Okay, and I say that's the worst because what? You basically cannot do anything, and it's not your fault. Okay, it's not that you are purposely sleep off, you purposely slack off like that. No, it's just like you can be so perfect person, and still because you're responsible on somebody else, that person gets sick, and you get distracted so badly that you cannot really come back. It happens before. If that's the case, don't blame yourself. Okay, if that's the case, don't blame yourself. Okay. On the other hand, if you do well, so far, I heard that you're, you're smiling there. That's good. You know, it's a very good, it's very good sign that you will be okay in this class. Now, keep the good work though. Don't slack off. Okay. Now, the thing is this: we know that using the same data, even I change this to sample, even if I change it to sample, these numbers here will turn out to be the same, exactly the same. Okay, if I change that to sample. Now, the thing is, suppose I change this to sample, what happened to the sample mean and the sample variance? Suppose the data set is from sample. Then, can you tell me the sample mean and the sample variance? Okay, the numbers up there, you know you will use the same number. Okay, just slightly different formula. Right? Now, let me give you maybe 2 or 3 minutes from now. Okay, let's see. The X bar, you see the mean computation will be the same even though we use different notation. So instead of mu, it's X bar. but the number will be the same. Okay, that's 17.625. Now, after this, I will teach you, I think after this, I will ask you to do another one example like this, and then I will teach you how to use calculator TI-84 to do row data and group data single point. Okay, yeah, so if you already have your TI-84, that's good. Then we can do that right away. If you don't have TI-84 yet, at least you already have the recording, such that once you have TI-84 at 10, or once you download the TI-84 emulator from that TI website, then you can try to do this. Okay, this will be sample size, the first number times the last number minus the middle number square over 16 times 15. I hope you get the same thing. Okay, I hope you have the same thing. And then this will be I get, this is 1.18333. Can anybody confirm if you get the same answer?
Yes, I got the same answers.
Okay, thank you. So square root of that guy will be 1.08781. Okay, that's if we have a data set that is from a sample. Okay, let's do one more, and then I will teach you how to use calculator to confirm your answer. So in my test, in my quiz, you still do it manually, but then as your secret, right? As your secret, you put it into calculator and see if you get the same answer. Okay, let me see which data can I use. Let me use this one. Let me use this one. Did I use that data? Yeah, not yet. Okay, let's use this one. So this is our example 6. This is our example 6. Now treat this as a sample. Okay, treat this as a sample. I know we still have one more case after this, group data interval, but group data interval computation based heavily on how you do your computation right now. Okay, yeah, so basically if you are not strong right now, you will have a lot harder time later on. Now from this data set, let me ask you to find the mean, I'm sorry, the mode, the median, you know what, let me move that a little bit to the right. The mode, the median, the first quartile, the third quartile, and then extend the table to find the sample mean. You need to write the notation correctly later on. I purposely write it in Word. And the variance. Okay, also use proper notation. Let me give you again, maybe 10 minutes. Okay, right now it's 10:55, so 11:05. Okay, do it please. 31.5 is in the middle. So they are 31 data. Position of the median is 31.5 data, so it's between data number 31st and data number 32nd. Okay, so there are the 31st data and 32nd data, and the median is right in between, right? But then it means in the lower half we have 31 data. The median of that lower half will be located at 31 plus 1 over 2. That's the 16th data. Data number 16, the first 14 is 4. So data number 16 is 5. Data number 16 from the top is 6. Okay, so I'm done with the first 4 questions and erase this. So the thing is, like, if people just look at my note, they don't really follow my lecture by video, they may not know how I get these numbers. Okay, they may not know how I get these numbers. So that also means the following: if you study from my recording, right? You may just look at my notes and work it out. If you get it, that you get the same answer, that's great. But if you somehow think, hey, you know what, Thomas, I don't know how you get this number, then you watch the recording. Okay. Only the first day of class lesson, basically the introduction, that I don't want to skip anything. For the rest, it's up to you. It's up to you. All I care is, like, when I give you the quiz, the test, the final, you do it the way I want it. Okay, it's not because I don't care at all. It's more about, like, hey, I give you that flexibility, and different students have different style of studying, right? Some people are smart enough to just learn from reading. Some people smart enough to learn from video. Okay, and some people needs both of them. Eight, 13, 14, so 343. So my sample mean x bar equals to 343 over 62. I get 5.53256. I hope that's what you get also.
Yes.
Thank you. It's 16,
Yeah.
25. Great. 649. With 2 of you responding yes, I actually come up with 2 conclusions. Means at least 2 of you actually work it out when I ask you to do so. Because there could be that some people just go on here and not paying attention, what's the purpose, right? Okay, I don't require you to attend this class anyway. I have the recording, right? But not only that you are actually do what I told you to do, but you also get it right, So yes, nice to know that. Thank you. This will be, what is this, 224? And 16 times 25, that's 16 quarters, right? So that's 417 times 36. I don't know, that's too big. That's 612. And 49 times 15, 735. That's 50 times 15 minus 15. Yeah, 735. So I add 612 plus 400 plus 2.4. I get 1971. So the variance, sample variance will be 62 times 1971 minus 343 squared over 62 times 61. I get 1.20386. Therefore, my sample standard deviation will be square root of that, which is 1.097257, so round to 1. Okay, now I hope this is what you get also, not only me, right?
That's what I got.
Great, thank you. Nice, nice. Let's go on with how to use calculator. Okay, let's go on with how to use calculator, at least to confirm our answer. Now, to use calculator, let's the calculator work. Calculator work. Now, we will learn how to input data. First, we will learn how to input data. And in case that you already have data in your calculator, then we need to erase that, right? So how to clear data? Let me write it down first. To clear data, you will punch stat. I will show you where it is later on. And then on the edit, you will clear list. Clear list. Okay, and then we have more things to punch after that. So let me show you my calculator here. This is my calculator. Okay, I go to stats. Okay, and then I go to edit first. Okay, you see that I already have data occupied my first and second column. That's L1, L2, which stands for list 1, list 2. Now, suppose I want to clear this up. Okay, suppose I want to clear this up. Then I go to stat. Okay, in the edit here, the big edit, you go to clear list. You go to clear list, option number 4. Now, I want to clear list 1 and list 2, right? Now, list 1 will be the blue L1 here. You see this above 1? You see this above 1? Okay, and L2, right? If you use handheld calculator, the actual calculator, I think the print will be yellow instead of blue. Instead of blue, yours will be yellow. So, but the punch will be the same. You go to second L1, comma, second L2, and then enter. Okay, this way, then your list will be empty now, ready to use. Okay, now how do we input data? How do we input data? You go to stat, edit, edit. So the first big edit, the second is small edit, like that, and then you input the data. Okay, and then you input the data. Let me write it down first. This will be stat, and then you go to big edit, small edit. And then you go to small edit. Okay, and then from there you input the data. Now, let's go to example 1. So we go back to example 1 here. Where's my calculator? Okay, then I will input this 8 data, 7, enter. 10, enter. You see my 10 is the second data, and 11 will be my third data. Okay, take a look here. You see this here? Do you see my pointer here? Okay, L1 parenthesis 3. So I'm about to input the third data in the first column. Okay, this is the third data, the fourth data, the fifth data, the sixth data, the seventh data, the eighth data. Now, actually, this kind of data, the order doesn't matter. Okay, so you can input the data after you put them in order. That's also fine. However, toward the end of the semester, the order of the data will be important for the last 2 or 3 weeks of this semester. For the last 2 or 3 weeks of this semester, the order of you inputting the data will be important. For now, you will see it's not that important. Okay, so I already input this data, right? Now, how do I compute? For example, I want to find the mean, the sum of x, the sum of x squared, right? And then sample variance, I'm sorry, population standard deviation and sample standard deviation. Let's take a look. To compute that, you go to stat again, but this time you move your cursor to calculate, and you choose the first option, one var stats, one variable statistics. Okay, now then it will ask you the list. Which list are you working on? List 1. Okay, now because it is a raw data, make sure you make your frequency list empty. Okay, and then calculate. That's what we get. Now compared to what we have here, you see your x bar is 8.5, right? Now if you notice, the computation for population mean and sample mean are the same. Therefore, our calculator will only give you x bar. That's because they can't really write mu nicely on calculator, okay? But because the results are the same, they will just give you x bar. Now, what happens if that's a population Thomas? Then you just write mu equals to the same 8.5, right? And notice that my x, sum of x is 68. You know what? Let me screenshot this so that you can do a comparison. Put it somewhere, maybe somewhere here. Let me put it somewhere here. Okay, so you see my sum of x is 68, sum of x squared is 600. Okay, now how about my population standard deviation? My population standard deviation according to my computation is this. Okay, but the actual one, if you don't do rounding, you see that we are accurate to 5 decimal places, right? Does it make sense? Now, and I remember, I think I scroll down, what happened if we have sample, then the sample standard deviation, 1.77281, 1.77281. So Thomas, hold on. If so, why don't you just let us use calculator then? On your sample test that you show us, would we use this method with our calculator to help us solve? No, no, no. The data is so big such that for you to plug in the numbers, the input the data only into the calculator will take you so long. Okay, and I show you this method. The main purpose is actually not so that you do it this way in your test. Okay, you don't expect what is my main purpose. The main purpose, me showing you how to use calculator, the main purpose is such that if one day, hopefully you get an A in this class and you apply to be a tutor at East LA College, okay, we have tutoring center, okay, they always need stats tutor, okay. Now then, when you apply to be a tutor, even if you get students whose teacher only let them use calculator, some teachers, they don't do it my way, right? They just tell the students, okay, just use calculator, right? You still can tutor them, That's actually my main purpose. Okay. And even if you don't get hired as a tutor there, I don't, that's actually one way to start. Okay. I would like you, again, if you get an A in my class, okay, I would like you to actually make yourself available. Thomas, can you refer me to your students for tutoring? Okay. And if you get an A in my class, I will ask you, okay, give me your phone number or your email, and I will announce that in my class. And when, of course, when I announce it, I will also say, hey, you know what? This student got an A in my class. Okay, so now he or she wants to tutor you. Okay, and that's a very good income, right? You can put $20 and people still pay you. Okay, in fact, on average, you can put $25 and people happily pay you. If you have group tutoring, let's say with 2 or 3 students, you can charge $30 to $35 per hour. Okay, and trust me, you don't need to pay tax for it. I mean, nobody report that kind of tutoring income, right? Okay, so my main purpose is so that one day I hope you can make this into money, right? Okay, please don't tell me, oh, Thomas, life is so hard right now, hard to make money. But when I give you a way to learn, then you say, oh, I don't want to learn it that way. Now, I have any tutor available? The tutor that I have has been tutoring for my students for quite a while. I don't really have tutors from last semester or previous semester, not because nobody got an A, no. It's more because most students who get an A in my class actually about to transfer. And once they transfer to university, they get busy with their own new environment, okay, new classes. Okay, so do I have any tutor? Let me give you the number I have. Give me a second. Give me a second. Let me delete this first. Let me delete this first so that don't confuse you. Let me delete this first, and then let me go down to how do we find the computation. How do we find how to get the x bar, which is equals to the mu on our calculator. Okay, and then the sum of x squared, and then s sub x, that's the sample standard deviation, population standard deviation. Okay, in fact, if I show you this calculator here, if you scroll down further, you see this arrow, okay, means you can go down further. That will give you the minimum, the first quartile, the median, the third quartile. Let's compare that. Let's compare that. Okay, I'm sorry, my daughter, I don't know what happened to her. Okay, so you see the median is 8.5, right? The first quartile is 7. But you see, my first quartile is 7. Where's my 7? Here, this is my first quartile, 7. But the way our calculator doing that, they don't show us how we get that 8.5, right? Okay. Well, but the answer is 8.5. How do you get that? How do you get that 8.5 while none of our data is 8.5? Then it must be because this 8.5 coming from between 2 numbers. Okay, but it doesn't show the computation, right? So the first quartile 7, the third quartile is 11. In fact, they show here also what is the minimum data and also the maximum data. Okay, that's from our calculator. So let me go back to the notation here. Give me a second. How to get this data and including the minimum, the maximum. Let me use capital M. The first quartile. I mean median, first quartile, and the third quartile. Okay, you will go to stat. Go to stat, and then go to calculate, and then one var stats. Okay, that's how you do it. Now then, let me check your notes, your chat. Switch devices. Okay, switch devices quick. What does it mean? You mean you change from one computer to another computer? Go ahead, go ahead. Don't worry about it. Okay, so this is how you get to the result. Okay, so you may need to clear the data first, and then you input the new one. You can also just key in the new data into L2, but then when they ask you calculate one for stats, right? Like, let me show you again. Stats, calculate one for stats. Now they will ask you, the calculator will ask you which list you are working on, right? So if your data is in list 2, then you put list 2 here, second L2, like that. You see what I mean? Okay. Now let's see, can you apply that idea to example 2? Let's see example 2. Now I want you to plug in these numbers into your calculator and then confirm that we get this. Okay, confirm that you get this guy, 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 and this guy. Okay, let me give you 1 to 3 minutes from now. Okay, we confirm that you got it right. The same with what we have here. Okay, now I will go on to what happens if we have group data single point. Now, unfortunately, I use TI-83 Plus in my handheld, okay, and I don't know how to actually do it using TI-83 Plus for group data single point. Okay, so group data for raw data. For raw data, TI-83 and TI-84 is okay. Now for group data single point, TI-84, at least the one on mine, I don't find a way to do it. Now TI-83 cannot do it, TI-84 still can do it. Okay, now let me show you how to do that. Let's say we take this example from example 4. We do example 4. Okay, we do example 4, how to plug that into our calculator. Now, I will do it this way. Go to stats. Okay, let's see. I think I have something occupied on my list 1. Okay, let me clear that first. So I will clear list 1. Now it's clear already. Now then, you need to plug these numbers in. L1 will be my data. Okay, so 3, and then 4, and then 5, and then 6, and then 7. Okay, then L2 has to be in that order matching the first one. My L2, the frequency is, for 3 is 2, frequency for 4 is 3, frequency for 5 is 5, frequency for 6 is 7, frequency for 7 is 3. Now, are you following me with your calculator? So you key in the data that way. Remember, the entry for list 2 has to be corresponding to the entry in list 1. Okay. Now then, how to do the computation? You go to stats the same way. Stats, calculate, one for stat. Now, this time they will ask you, where's the list from? My list is from L1, right? I already have that. But because this is a group data, we have the frequency list, which is our L2. Okay, then calculate. This is what we get. This is what we get. Okay, let's screenshot this and put it somewhere that we can compare to. Okay, let me put it here. Okay, so you see my X bar or my mu is 5.3, the same, right? Okay, and then sum of X is 106, sum of X squared 590. Okay, now because this is a population, of course, you don't read this one. Don't read this one, you read this one instead. Okay, which is the same to this. You see that? Okay. Now, any questions so far? So basically the same way, right? Basically the same way. The nice thing about our TI-84, you see, why TI-83 different from TI-84? What's the difference? This is one of the difference. TI-84 can handle group data, single point, and TI-83 cannot. Okay, TI-83 cannot. In fact, if I go back to my calculator and I scroll down, it will give me the first quartile. You see my first quartile is 4.5. The median is 5.5. The third quartile is 6. Okay, but notice until now, our calculator does not show us what's the mode. Okay, calculator cannot show us what's the mode, which is actually supposed to be easy, right? I mean, just look at that. The way we answer the mode equals to 6 here is just by looking at that. But I had students, trust me, it's just like I have students repeating the class from other teacher. They come to my class. They think that they are so good that they don't need to learn from me. So they never really pay attention until when the quiz comes. It's like that student suddenly asked me, Thomas, what is mode? It's not on my calculator. So well, I never really teach you how to use calculator anyway, right? So why you suddenly ask me why it's not on your calculator as if it's my fault? Okay, and then that student starts saying, well, that's how I learned it from my previous teacher. And I have to yell at that students. Imagine in class. Imagine in class, I yell at that students. I'm not an instructor who won't yell at my students. I do yell. Why? Because if you don't listen and you are at the risk of not doing well in my class, and I know you are going to wrong direction, I will yell at you so that you repent, not so that you drop the class. Okay. Once I don't care about a particular students, I basically saying to that students, you know what? Doesn't matter. You're not passing this class anyway. And I'm not that kind of teacher. Okay? I'm someone who I decided to be a professor since I was in middle school. Okay, so this is what I want to do since a long time ago. I don't get this job because I'm not qualified for other job. No. Okay, I want this job. Okay, I have my passion to train students to be better, if possible, better than me. Okay, now, so please be aware that mode is not something you can verify using your calculator, but it's something easy to see anyway. Okay, now let's go back. We still have one case that we have not done. What happens if the data is provided to us? Oh, you know what? Let me ask you to confirm that you know how to do that using this data. Use your calculator for this example 6. Use your calculator for this example 6. Confirm that you get n is 62. Okay. And then the sum of x is 343 and sum of x squared is 1971. The sample mean, sample standard deviation, the median, first quartile, third quartile. Okay, I give you maybe 3 minutes from now. Try to do that. Okay, this is what I get. This is what I get. So what is my X bar? My X bar is here, 5.5325. Huh? 22. Why I get it different? Hmm? Hey, do I write that incorrectly? Let me see. What is 343 divided by 62? Unless I think. Oh, I don't have to go. No, I wrote it wrong here. I wrote it wrong here. Good thing I checked that. Now, when you actually divide 343 divided by 62, this is not the number. That's not the number. So I did it right, but I wrote the wrong number. Should be 5.53226. Okay, good thing I checked. But my 343 divided by 62 is the correct one. It's just like when I use my calculator to compute this, that's not what I get earlier. It's this one. Okay, so I confirm this, and then the sum of x is this guy, confirm. The sum of x squared is this guy, confirm. Sample standard deviation 1.0972, supposed to be 0, but because the next number is 5, I round it up. Okay, and then the n is 62. Okay, the first quartile is 5. The first quartile is 5. The median is 6. The third quartile is 6. Right? Okay, so let me erase that. Oh, you know what? I will just leave it there. I want to get rid of this screenshot, but yeah, I guess I will just leave it there. Now, the next part. The next part is what happens if we have group data interval. Group data interval. So we will go back to manual mode. Okay, we'll go back to manual mode. The population mean and sample mean. What are the formulas? Population variance and population and sample variance. What's the formula? So the mean will be the mu equals to the sum of fxi over n. Oh, what is that I times? First time seeing that. The midpoint. Fxi over n. So you will see the formula is exactly the same to group data single point, except that for each x, you do xi instead of simply x. Now that xi represent midpoints. Okay, so the formula is supposed to look like this in the group data single point. This is the formula for group data single point. Now, what happens if we have interval case? Then all the x, you make it xi, subscript I. Okay, that's the new stuff. That's the new stuff. Basically, before we multiply the x by, which is an interval with the frequency, we get the midpoint of that interval first. Okay. For sample variance, the formula is still the same, except again, you insert subscript I. Okay, you insert subscript I. I will do one example for you. Okay, and then I will ask you to do it on your own. And then I teach you how to use calculator, because group data interval is actually not doable even on TI-84 unless you know how to get around that. Okay, unless you know how to get around that. Now, but let's see example 7. Let's see example 7. This one, give me a second. Example 7, let's do, oh, not this one either. This one. Suppose we have this group data interval frequency distribution whose entries are intervals. Make it larger so that we can see better. And suppose this is a population. Okay. Now, what does this interval mean? Now, the thing is sometimes we have too much data, or the data varies so much such that it's impossible or meaningless for us to do them in the way we did earlier. Okay. So instead of doing group data single point, we do group data interval. Now, what happens then in the class of 2 to 6, you see the frequency is 2, right? The frequency is 2. Okay, it happens twice. But what happened then, we don't know precisely what are the data. And in other words, in this class here, it could be that the data actually 2 and 2. But if the data is 2 and 6, it will look the same. Okay, if the data is 2 and 6, it will look the same. If the data is 2 and 4, it will look the same. In fact, the data may be 5 and 6, maybe. Okay, so I mean, we already lost some. Accuracy here. Now going back, is the one I highlight above I or 1? I. X, I. So X subscript I. Subscript I means it's smaller and lower. Okay, not X1. No, not X1. It's Xi. Okay, the I represent the midpoint of a certain class. Now coming back here. Now, so for example, class 12 to 16. The class of 12 to 16, we see the frequency is 5, right? The frequency is 5. But it is not clear if these 5, all of them 12 maybe? Or maybe 112 and then 113, 114, 115, 116, right? In other words, if your data looks like this, then it will register in this frequency distribution that way. Likewise, if your data looks like this, it will register the same way. Okay. Therefore, by doing group data interval, we already lost some accuracy. Okay, so our answer will not be accurate anymore, but the purpose of statistic is not to get the accurate answer only. Of course, right now, you need to get the accurate answer given that number, those numbers, right? But when we do inferential statistic in the last step of this class, like the last 5 or 6 weeks of this class, then it's all we use, even though the number we get are approximations, but we still try to estimate and make decision based on those data. Okay, even though it's not accurate, but it doesn't mean it's totally wrong. Okay, let's say for example, suppose the average GPA of all East LA college students is 3.415796, let's say like that. Okay, and then it turns out that when we compute it our own way and do some kind of like strange estimation, so on and so forth, we end up with 3.4 only. Okay, or let's say we do sample of 400 students instead, and we get 3.4. But Thomas, you see that your mu is not accurate anymore. The sample, from the sample you get the average GPA is 3.4, while it is supposed to be 3.415 something. Okay, yeah, I mean, when we do sampling, we don't expect that to be super accurate anyway. However, what is important is, what do you say about these numbers? If you say 3.415 GPA implies East LA college students are smart, will you come up with different decision if the number were 3.4? It's just a little bit off, right? Will you change your mind? No, it's not more than 3.41. It's 3.4, right? No, I don't think so. You will come up with the same decision, right? Okay, if the average GPA is supposed to be this, and then somebody give you this, will you criticize me for not being accurate? Thomas, you are not accurate. Well, does it matter? Will you come up with the same decision? Will you do exactly the same thing anyway? Right? Okay, and that's the purpose of statistic though. The purpose of statistic is, can we use limited informations based on the data we have to make decision for unlimited future. Okay, now I use this illustration. You can consider this joking, but no, I'm actually not joking. We more or less apply sampling to make decision by, in our daily life, by, for example, dating. In case of dating, okay, what is the reason we dating? It's to collect samples, right? You try to hang out with that person, that guy or that girl, for a couple of days, which I don't recommend, okay? Preferably maybe 2 or 3 years, 4 years, right? Such that you have a very big sample size, right? Many, many, many days. And in those days, you have sweet time, you have rough time, you argue and get back together. It's possible that you broke up a couple of times in between and still come back together. Okay, and then after a large sample size, you come up with a good approximation. Can I live with this person? Or to be more precise, can I live without this person? That's the purpose of dating. You collect samples. Is it possible that the result you get from dating different from the result after you get married? It's possible, but very unlikely. Right? Very unlikely. If your dating is done correctly, then what you know about that person during your dating time should be the same to what you expect that person to be after you get married. Right? Now, of course, the data you have from dating may be different. If you only do it like couple days, like you date for like 20 days and then suddenly decide to get married and you get married right away. With that small sample size, of course, the level of possible bias is very high. That's why I never recommend anybody, like I was quite active at church before, right? And people ask me, Thomas, how long should I date my girlfriend? Like a guy-to-guy conversation. I think I'm really good with this lady already. Really match so far. Okay, we've been dating for 1 month, and my age, her age, already quite mature. So I don't think we will have any deviation. Should we get married? I say, no, not yet. If I were you, I will make it at least 1 year. Okay, because your love springs in the spring semester, but fall in the fall semester. right? Okay, we never know. We never know. So I recommend that person to continue dating for at least 1 year. Okay, but the purpose of dating is basically collecting sample and then get a better estimation. Okay, now I'm not saying that after this long dating, then you have for sure you have a good marriage. No, no, no. It is still possible that when you get married, you end up with different husband that you didn't expect, or different wife that you didn't expect. It's still possible. Okay, but if after long dating that could happen, imagine if you don't date long enough, right? Okay, so I get comments, this is great advice, facts, and so on and so forth. I'm just trying to show you that doing sampling and doing estimation and infer from those data is actually something we do even before we learn statistics. Okay, okay, and if you can learn from somebody else's statistic, will be even better, right? Don't you think so? Like from your parents, right? That's actually the source of good statistic. They may make mistakes themselves in their life, but I still believe like most parents, if not all, will give the bread instead of stone to their children, right? However bad your parents, when you ask them for advice, they will give you the best advice they can think of for you. Okay, even if they themselves not doing well in their marriage, you still can ask them, you know what, I have this situation. Okay, what advice can you give? And you may learn from their mistakes also. I mean, some people still, even though they make mistakes, they still can learn from their mistakes and share it, right? If you are not my, if my son asks me that question, I can share with my son whatever mistake I ever made in the past, and hopefully he doesn't need to make that mistake. Okay. Now, of course, I don't think I need to share all my life, my mistakes to my students, right? Okay, mistakes in statistics, yes, but mistakes in life, my marriage, nah, no, too much information for you. But anyway, at least now you know that dating is actually one example of collecting samples, and hopefully with the larger sample size. That's therefore never date for only couple days ever. Okay. Do you believe in love at the first sight, Thomas? Yes, I believe in the love in the first sight. I don't believe in marriage from first sight. No, that's not what I believe. Okay, no, don't get married after you look at that person, because I fall in love to Jennifer Aniston at the first sight, but I will never marry her simply because she will never marry me. Okay, I may want her, but she doesn't want me. Too bad, right? Okay, so in you never know, Thomas. Yeah, I never know, but now I know. Now I know. No. Okay, at least one thing I know for sure: I love math so much, and she doesn't like math at all. Right? Maybe some. Okay, maybe math as METH instead of MATH. Yeah, you miss 100% of the shot if you don't take. You know, how many shots do I have anyway? If I have unlimited shot, then I will shoot everywhere, right? The thing is, no, I only live for some time. So even if I know that's right, if I don't take any shot, then I will never have a chance. But if you have limited shots, if you have only 6 bullets in your gun, you don't want to shoot everywhere. No, right? Okay, especially to be honest with you, some personal story. Okay, in my lifetime, I did it 6 times. Before my 7th dating, then we get so serious. I married at the 7th date. So I basically lost all my bullet in my gun already if I have only 6 bullets in the barrel, right? Okay. But then my 7th shot is the one I make. Okay. Imagine if I just keep on shooting, then people will know me not as an instructor, math instructor. They know me as a Don Juan instead. You know Don Juan? Read the history. Okay, no. That's a bad one. That's a bad one. Well, anyway, coming back here. So this population, if it is provided to us in group data interval, it already lost some accuracy. For that reason, then we can answer the question, what's the mode? Or what's the median? Not to say, of course, if you can't even answer the median, then you won't be able to answer the question, what is the first quartile or the third quartile? Okay, the most we can answer is what is the mode class? What is the mode class? And here the mode class will be the class of 12 to 16. You see what I mean? We can answer the median class, the class where the median located. Okay, here we have a total of 12. So 12 plus 1, 13 divided by 2, 6.5. So data number 6 and data number 7. Data number 6 and 7, where is it located? We have 2, the total of 5 up to here, up to this one, 10. So data number 6 and 7 is in the class of 12 to 16. Okay, we can find the class where the first quartile is located. Okay, the median is the 6.5 data. So the lower half must have 6 data, right? Plus 1 divided by 2, that's 3.5 data. The third and the fourth data. Now, third and the fourth data located where? In which class? 7 to 11. Again, so we don't know what's the first quartile, but we can tell where the first quartile located. Okay, now if you have a chance to go on further in statistic, then in higher statistic, 400 level or 300 level, then they will teach you how to approximate the median. So more computation, which is not too heavy, but heavy enough, which I will not teach you in this class. Okay, it's heavy enough though. It's heavy enough. So in my class right now, I only teach you how to find the median class, the first quartile class, and then the third quartile class, which is from 12 to 16 also. Okay, we cannot answer precisely what's the mode. We cannot answer precisely what's the mean. We can only locate, we cannot answer precisely what's the median. We can only locate the class where the median located. Okay, now, then how about the mean and the variance, Thomas? Now, we basically do what we did earlier with the extension with one extra step. We need to find the midpoint for each class first. Now, the midpoint for each class is done by finding the average of the lower class limit and upper class limit of that class. So xi is equal to 2 plus 6 over 2. The midpoint of the lower class limit of that class and the upper class limit for that class. Okay, that's the midpoint for that class. For the second class, the lower class limit is 7. Upper class limit is 11. So the midpoint is 7 plus 11 over 2, which is 9. Okay, now I will ask you to extend this on your own, but you will see that we basically insert that xi, but once we get that xi, then the next extension will be f times xi, and the second extension will be xi squared n fxi squared. Okay, so for example, this guy here will be 2 times 4. That is 8 here. Xi squared is that 4 squared. I get 16. This guy here, xi squared from here. And then fxi squared is f multiplied by xi squared. That's 32. Okay. Now let me ask you to complete this table. If you are following me, let me give you some time to complete this table, maybe 2 or 3 minutes from now. Let's finish this one and then I give you another example together with your long break. Okay, let's finish this one first. So this guy is 28 divided by 2. So this is 14. This guy is 38 divided by 2 is 19. You don't need to show this anymore though. Actually in your test or your quiz, you don't need to show this anymore. Okay, I show it here because if somebody asks me, Thomas, how do you get that 4? How do you get that 9? And you can, from what I write here, you know how I get those, right? But I hope then you then know how to get this 14 and 19. Complete this in 2 or 3 minutes. Okay, let me work on that while waiting for you finishing up. So this is 27, this is 81, 81 times 3, 243. F times x, this is 70, 14 squared, 106. F times x squared, divided by 2, that's 980. This is 38, x squared 3, 61, 722. So fx being added, there will be a plus 0.7 plus 70 plus 38. I get 143. 32 plus 243 plus 980 plus 7.2 and 377. Okay, now this will be my first number, my second number, my third number. Okay, so you will see that the only new stuff, the only new thing here is the insertion of this xi first. Okay, the midpoint, and we use this midpoint xi to extend our table the way we did in the group data single point. Okay, with that said, then what is the population mean? So the mu will be 143 over 12, which is 11.91667, while the population variance will be 12 times 1977 minus 143 squared over 12 squared. I get 22.743055 something 06. Therefore, my population standard deviation is the square root of that. It's 4.76897. Okay, so the procedure after you get that table, the three important numbers, the procedure will be exactly the same with what we did before. In this case is population, but you still can adjust that if this were a sample. Okay, and in fact, I believe if you are really good with the one in single point case, then this type of extension is something quite natural for you. And you just realize that we basically add this one step before we do this step here. Okay, before we do this step here. Okay, let me give you one problem. Okay, do you need more time to copy this down? Well, let me ask you to copy that down first then, while I look for more questions for you to work on. Okay, so I assume you're already done with that. Okay, let's do this one. Call this example 8. This is example 8, and assume that's a sample from a sample. Okay, what I want you to do is just to find the mean, the sample mean, of course, the mean, and the variance, and therefore, after one little step, you will get the standard deviation. Okay, I give you approximately 30 minutes break and then approximately 5 minutes to do this problem. You don't need to do the mode median thing, just the mean, variance, standard deviation. Okay, but remember this is a sample, so you need to adjust the notation, and of course for the variance formula also you need to adjust. We come back at 35 minutes up this 45. We come back at 12:50. No, 12:50 will be too much. Yeah, that's right. 12:50. We come back at 12:50. Okay. Okay, so this is what I get. Then the sample mean will be x bar equals to 664 over 31. That's 21.41935. The variance, which is sigma squared, will be 31 times 15,066 minus 664 squared over 31 times 30, because that's sample. I get 28.11828. Then the square root of that, sorry, I used wrong notation earlier. It should be s squared, not sigma squared. It's a sample. Right? So s equals to square root of 28.11828. The square root of that will be 5.30267. Okay. Now, I'm about to be done with this first part here, with the heavy part of our class today. Now, how can we check? How can we check our work? By calculator. This is what you can do. Okay. Remember entering, inputting x into L1 and frequency into L2. When you input those data. Now, what you can do instead, now you change that. You input xi into L1. So your L1 will be from here. Okay, and this will be your L2. You see what I mean? Yeah, you input L1 from xi, the column of xi, and the f from L2, just to confirm your answer, right? Just to confirm your answer. Okay, let's try to do that. So let me go to my stats, edit. I need to clean this up. You know what? I will just write on the top of it. So I cleaned it up. Clear list 1, comma, list 2. Okay, so I'm teaching you how to cheat a little bit, right? Like if I want to get the answers, just to confirm my work, right? So notice that what we did before when we have group data group data single point, the x is in the first column, right? Now you replace that x by xi. Okay, and then the second column will still be our frequency. Okay, and then I go to stat, calculate one var stat. Still, the list is from the data from L1, the frequency list from L2, calculate. Let's see what we have here. I make a mistake somewhere. This is not the number I'm supposed to have. No, this is not the number I'm supposed to have. It's totally wrong, Thomas. Let's see. Did I plug in wrong data? 19, 24, 21. Oh, my last one. My frequency for the last one is wrong. It's supposed to be only 6. Yeah, not 16. Okay, go back. I was so scared that's wrong. This one, this 2. Now I get it. Okay, right? So you see my x bar is 21.419354 something. Okay, and sum of x is 664. Sum of x squared 15,066. The number of data is 31. And sample standard deviation is 5.3230267. Okay, so this is the way you kind of like go around because again, when you try to plug in your list 1, which is where your data, okay, we cannot input the interval, so we input the midpoint instead of the interval. Okay, that's how we kind of like get around this. Now, let me tell you some story. I mean, this is a story, some background. Remember I told you like around 5 years ago, I still let students use TI-83, right? Basically using regular calculator because I assume a lot of students cannot afford the TI calculator. So you see, even before pandemic, I already have in mind that how to save my students money. And for East LA College, I was the person who been using the 10th edition until last year. Actually, even until last year. Okay, so students can get the book from Amazon for only $10, already including shipping. And students still can rent it from the ASU. They can ASU or ASO, okay, Associated Student Union, Associated Student Organization for $10 per semester. Okay, that's how I try to save your money. And then I have more and more students in my class can afford TI-83 and 84. And also some background story. I have two instructors one at East LA College and one at West LA College. For some strange reason, they kind of like accused me something that I'm so offended. It's like, oh, Thomas, I know Thomas don't use calculator because he doesn't know how to use it. I was like, what the heck? Why do you need to say that? And those instructors actually say that in front of students. So it's more like this. It's not like that person didn't appreciate me trying to show the background work. Okay, instead attacking me because I don't know how to use calculator. It's just like, dude, even my website that I show you, I programmed that myself. I wrote the code myself. Okay, it's not that I just use the template and then copy paste here and there. No, 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 no. Okay, I actually coded myself. Okay, yes, most of them actually template, but then I need to change the code here and there. But I still need to know how to read the HTML coding. Okay, the JavaScript. Okay, the RSS. Basically, more than half of the programming, the coding is actually done by me myself, from the raw coding, HTML coding. Okay, and these people is like, I know they don't even have a website, they don't know how to code anything, and then they're enough to challenge me like, Thomas, you just don't know how to use calculator. Okay, so it's just like, well, tell me which part you want me to compute. And then it turns out they don't even know how to get around the system when we have group data interval. So I was just like, you say that I don't know, and it turns out that you're the one don't even know how to manipulate your calculator. That's quite strange, right? Okay, and that kind of like pissed me off a little bit. And then it's like, hey, since most of my students can afford it already, let's just use TI-83 and 84. Okay, and during the last 2 years, I think the last 2 years or the last 1 year, then I insist on TI-84. While if you still use TI-83, that's fine, don't worry about it. Whatever missing from TI-83, it turns out that we can program that into something similar to TI-84, okay, for important part. Okay, now I was a student before, and I was a poor student. I mean, the way I see is like, since we are students, like you are students and I was a student before, then we actually need to focus on studying, and therefore we cannot focus on working, you know, okay? So since we cannot focus on working and earning money, then yeah, money becomes something scarce for us. Try to save as much as possible. I have one very well-known instructor actually at East LA College. I don't want to say his name. He's someone I respect though, don't get me wrong. I respect him so much. But he made this comment about, this is an instructor who insists students to use the newest edition, okay, the 13th edition. Once the 13th edition come out, he insists to use 13th edition while I'm still at the 10th edition. And if the 14th edition coming out, trust me, he will insist on 14th edition. And he also insists of using a software called My Math Lab, which may cost student another extra $100. So the book itself already $100 something if you don't get the PDF file, right? If you buy the book, okay, which is bundled with the code, it may cost you like $200. Together with the calculator, a total of $300 just for the infrastructure, just for the book, My Math Lab, and TI-84. But the thing is, like, that's for just one class, it's already $300. How about the rest? Now, the thing is, like, he argued this way though. He argued this way, and $300, yes. That's without tax, I'm sorry. That's not including tax, okay? Now, the thing is, I did ask him, I mean, our students are not doing well financially, right? I mean, okay, some students are actually okay, but we should not assume that every students are okay. And even if they're okay, what's wrong with us trying to save them some money, okay? Such that they can have more money to do something else, okay? Yes, the one who are like pretty rich, it won't affect them, right? But how about those students who need to really split even the dime? I mean, imagine a part-time student who become part-time student because they don't have enough financial resource to come to school full-time. And they need to work part-time, not to say that who knows, they are actually they are actually moms with children at home. I mean, that's another financial burden though. Okay, what's wrong with us trying to do something for them? And you know what he say, that it's a male instructor. This is what he say, Thomas, look at what they use. They use iPhone 10. I was like, so what if they use iPhone 10? Okay, first of all, that statement is not true. Okay, because most students, okay, even though if most students use iPhone, not all of them use iPhone 10. That's one, okay? I'm not talking about those people who don't need help, okay? If they don't need help and we save them money, they will not yell at us. But if they need help and we don't help them save money with what we can do, we basically restrict them from education opportunity. And later on, we say, oh, you know what? We have so many students cannot transfer, while you are actually part of the problem, dude. Right? You are part of the problem because you make their cost of education so expensive. And why do you compare that with iPhone 10? Yes, iPhone 10 is like thousands of dollars, $1,000. I don't, my smartphone is Galaxy Note 4. Okay, I got it like 6 years ago, 7 years ago. And I still use this okay. Of course, if you can be thrifty, you can save money, why not, right? But how about us How about us trying to help students, regardless they need that help or not, right? With this thing, everybody will appreciate that. You appreciate me right now, right? Okay, students who don't need help, they will still say thank you, especially those students who need help. They will give you a big thank you, right? His class is always full though. His class is always full because it turns out later on, I find out that he's just a calculator instructor. And he keeps on saying that, oh, you know what, Thomas, however I try to explain to them, they won't get it anyway. What? You think so low about your student? And they will not take statistic class anyway in future. It's like, well, if you don't teach them well, you disable them from take the next statistic class. The reason they don't take the next statistic class, because you already disabled them in the first place. Okay, just like why you cannot take calculus, because I already cut your limbs even in algebra by not teaching you the right way. Okay, blame it on the teacher. Okay, but of course, if I do what I supposed to do, I teach you right, and you still choose not to go to calculus, of course, at least I still give you the option, right? But not teaching you right, and then say, oh, the student will not go to calculus anyway. You are degrading students. You are cutting away the opportunities that you're supposed to provide them. That's what education is supposed to be. Okay, well, anyway, that's a little story from me, what happened at that time. So I was just like, okay, you know what I will do? I will teach it the right way, but I will also teach my students how to use calculator. And you know what's the purpose? So that my students can tutor his students and make money from his students. Now, if you are still on campus, if we go back to campus, you will see some people actually post flyers around campus to tutor statistics. Okay, some of them actually my students. Some of them actually my students. Why? Because I tell them, it's like, you know what? Their teachers actually don't teach them right. They need a tutor who can tutor them right, and that's the time you can make money. Hey, students sucking money from other students, I'm for it. Go for it. Okay, who told you choose wrong teacher such that you need a tutor? How about you take a right teacher, you don't need a tutor, but once you pass this class, you become a tutor and make money from other students. Okay, believe it or not, I have one student, maybe even two, make $2,000 every month during regular semester, even during winter and summer, just for tutoring statistics. $2,000 per month, side job, and you don't report tax on that. You know what's the best part? She's a mom. Okay, she said, Thomas, because I can tutor a site, then I basically don't need to go to work the way I did it before. I have little kids at home. Okay, I can choose when to tutor. I can cancel I can postpone the tutoring. It's basically up to me to decide. And what do you think the better job than being a tutor or being a teacher? Think of that. You know, this is the only time you can talk and get paid. You sit down, talk, and get paid. Not like other job where other people talk, you have to listen and follow what that person say to get paid, right? And my wife, of course, this is a little bit joking. My wife wonder why I like teaching so much. Because when I go teach, I talk and I get paid. When I stay at home, you talk and I still need to pay. Of course, this is partly joking. Okay, if I stay home, you will ask me, Thomas, we need this, we need this, we need this. You need to buy this, you need to buy this, you need to buy this. Okay, that's why I prefer going to teach. Why? Because I can talk and still get money. Well, anyway, yeah. I hope you remember my purpose. Try to get that A. I think even if you get a B, you still can tutor though, supposedly. Okay. Yeah. Hopefully, then you can recover some money by tutoring after you pass this class. And trust me, after a while you will enjoy it. I'm not alone. I'm not alone when I say this. I'm not alone. I know for sure I'm not alone. Okay, now I will go on to the second part. I know the time we have is just a little bit, only around 10 minutes. But what I'm about to do in the second part also just a little bit. Okay, it's part 2. That is a more detailed explanation about frequency distribution or group data interval. Okay, some terminology. Let me extend this. Okay, the first one is lower class limit. Lower class limit. Let me write it above. Lower class limit is the number on the class that is registered. Now, these are the lower class limits for each corresponding class. Okay, so whatever registered there, that's the lower class limit. Okay, now upper class limit, that's for upper class limit. That's the largest number registered for that class. That's 16, 21, 26, 31. Now, I think this is easy enough, right? For lower class limit, upper class limit. Now, slightly harder, but of course not in any way considered hard. Slightly harder is something called boundaries. Lower class boundaries and upper class boundaries. Lower, upper class boundaries. Okay, now what's that? Let me explain it this way first. Imagine a number line. Imagine a number line with your classes there. So your classes is between 12 to 16. That's the first class. The second class is 17 to 21. The third class is 22 to 26. And the last class is from 27 to 31. Now, let's say these intervals here are your houses and with your adjacent, with your neighbors, right? With the adjacent houses. Now, the thing is, we would like to know the fence. Where should the fence be located? Now, the fence will be located right in the middle between your wall. Okay, right in the middle between your wall. Okay, now that's the boundaries. Those are the boundaries. Okay, suppose these numbers here, 12 to 16, 17 to 21, all the way to 31, are actually the age of students in Thomas' class. Let's say these are the ages of students in Thomas' class. Okay, of course, if somebody asks you, how old are you? Oh, I'm 16. Oh, I'm 18. Okay, but there are times somebody happen to fall into the gap. For example, how old are you? I'm 16 years, 3 months. Now, then should that person be in 12 to 16 class or 17 to 21 class? How do we decide? We take a look at the boundary of each class, okay, which is the midpoint between the upper class limit of the lower class and lower class limit of the upper class. Let me say it again. Okay, for this first class here between 12 to 16, the boundary here, this guy here, okay, the upper class boundary for this class is the midpoint between the upper class limit for this class and the lower class limit for the next class. That's the boundary, which is 16.5. Okay, so I get 16.5 here from where? 16 plus 17 over 2 equals to 16.5. Okay, so this 16 from there, this 17 from the other one, 16.5 is the boundary. Now, boundaries are the one shared with your neighbor. Okay, so this 16.5 is also a boundary for your neighbor, but that will be the lower class boundary for your neighbor. Okay, now upper class boundary for the next class is 21 plus 22 over 2, which is 21.5, right? Okay, for this second class here, for this second class, the upper class boundary is the midpoint between this guy and that guy. Can you visualize that? Okay. Now, so if somebody is 16 years old and 3 months, well, that's 16.25 years. So that person still fall into the first class. Okay, still fall into this class. But if that person, let's say, is 16 years and 10 months, it's almost 17. Then, according to this cutoff, well, the cutoff for the first class is 16.5, right? 16 and a half year. If that person is more than 16 and a half year, 16 years, 10 months, that person already here. Now, technically, that person is not in the second class yet, 17 to 21, but it is still more appropriate to put that person into this class than into this class. Does it make sense right now why we need to have these boundaries? Okay. It gives us a better cutoff. Okay, instead of just the what's that? What you call the nominal cutoff, like the first class 12 to 16. So what happened if that person is 16.3? Well, still on 16. Why? Because the boundary is actually 16.5. Okay. Now I continue. So this 21.5 is also the lower class boundary for the next class. The upper class boundary for the next class is 26.5, which is the lower class boundary for the next class. Okay. So you will see that these two numbers should be the same. Those two numbers should be the same. Now, let me go on. Now, with this said then, what is the lower class boundary for the first class? And what is the upper class boundary for the highest class? We cannot say it this way. We cannot say it this way. Let's say you happen to live in a neighborhood, right, on the street, and yes, you have boundaries here, right? You have boundaries here. And it turns out that you have empty space here, you have empty space there. Now, whom this empty space belong to? Whom this empty space belong to? Do they belong to this house on the left here? And the empty space on the right belong to the house on the right there? I mean, that would be nice if you live there, right? But the thing is, when you purchase your house, you only purchase it from here, though. So what makes you think you have right over this place? Right? No, it doesn't work that way. It doesn't work that way. Okay, even when you buy a house and there's empty space next to your house, that's still not yours. Doesn't mean you can go there and you can build anything there without, it's not mine, so I don't need permit, but it is mine because I'm the one building something there. So is it yours or not? Right? So then there must be a boundary here. How do you know what's the boundary? Then based on how far you go to the right here, that's also how far you go to the left there. Okay, based on how far you go to the left here, that's how far you go to the right there. Okay, now so you see between the upper class limit and the upper class boundary is 0.5 units. 0.5 unit. So when you go backward, right, this will be 12 minus 0.5. That's how we get that 11.5. Okay, so yes, because you go to the right half unit to 16.5, so you have half unit to the left also here, but anything to the left here is not yours. Okay, to be more precise, it's everybody's, because nobody belongs to, that place is not belong to anybody, then everybody can use that, right? Okay, and if something goes wrong there, everybody should shut up. Of course, I make up solution. Okay, with the same idea, then from here, you increase by the gap half unit. Therefore, the upper class boundary here will be 31.5. Okay, in the last 2 minutes, one more thing, relative frequency. Relative frequency is the frequency for that class divided by the total. The total is 31 here. So this is 7/31. Relative frequency for the second class is 8/31. The relative frequency for the third class is 10/31. And the relative frequency for the last class is 6/31. Okay. Now, when you do frequency distribution, you need to get the total. And you also need to get the total here. In practice, relative frequency is usually written in percentage, 3 decimal place, or maybe just, but usually in percentage or in decimal. Most of the time, not in fraction. To make your life easier, I allow you to write it only in fraction in class. Just don't forget, you still need to add them and make sure the total is 1. Okay, that becomes relative frequency becomes the first definition of probability, which we will use next week. Okay, now what part I didn't go over today, I think this part is easy, but there's one part in my lecture too that I don't go over today, is, and I expect you to learn it on your own, that is learn on your own. Maybe next week I will go over this a little bit. Learn to construct frequency distribution given raw data. Okay, I think next week that will be the first topic we do. Okay, if we have a very big data, okay, let's say a size of 200, let's say, how do we construct frequency distribution from there? And then from that frequency distribution, we compute the mean, the variance, standard deviation. Okay, this is where I will stop. It's already 1:20. And this is where I will stop. See you next week. By next week, which is our third meeting, you should have watched lesson 3 from announcement 3. Is it okay? Okay, see you then next week.